A very warm welcome and a very good afternoon. So I know you have a lot of choices and sessions, so thank you for your time today, and we welcome you coming in and learn a bit about storage in the Windows Server 2016 Technical Preview 2 and the Microsoft Azure Stack. Just a quick round of introductions. I have a couple of my colleagues here who are going to do demos, and my name is Siddhartha Roy. I'm the Group Program Manager for High Availability and Storage in the Windows Server team. I get to be the talking head for a lot of the good work which a lot of the team is doing at Microsoft. Along with me is going to be Jose Barreto, who's going to present as well. And then I have Klaus Jorgensen and Netpile in my team as well, who are going to do us some couple of great demos as well. So with that, I'd like to kick this off a bit. So first of all, just a bit of grounding. I know you have been getting a lot of information in the last 24 hours about, the cloud-inspired infrastructure, the consistent service delivery, and the cloud-optimized app platform. You heard Jeffrey Snover and Mark Russinovich talk about this yesterday. And everything together is coming up in what we call Microsoft Azure Stack. So just wanted to ground you in, you heard the top-level keynote session, and you have been going through a series of platform overview sessions. This is the storage session, the fourth in the series of 7 you will hear today and tomorrow. So I welcome you to check out the other sessions after storage, security, what's new in System Center, and also Linux as well. And hopefully you got a chance to attend the ones before me in terms of software-defined network and compute. So let's delve in a bit. In addition, I'm not going to spend a whole lot of time. We have a bunch of great storage sessions lined up today and tomorrow and leading into Thursday. And as we go through the topics, you will see a little call out at the top of the slide which will tell you which session exactly you need to go and attend. So welcome you to check that out, and that will offer you great deeper dives on your topics of interest. And hopefully you can engage with the folks working on the product right there. So let me begin a little bit about, giving a little bit preamble on software-defined storage. I mean, you have all heard about software-defined storage, but, depending on the interpretation, it can mean many different things to many different people. So before I go there in software-defined storage, let me talk a bit about Azure. If you have seen the theme recurring throughout the last 24 hours, it's about how can we bring the Azure cost and scale design points down to the private cloud. It's either the customer's private cloud or the hosted private cloud. That's what a lot of customers have been asking us for. I mean, give me the cost and scale economics of Azure, but bring it to my data center so I can deploy that and manage that in my own terms, okay? So that's exactly what we did. There's a lot of cross-pollination you will hear today in terms of what we brought down from Azure and also what we kind of pushed into Azure. So it's kind of little known that, not just Azure, but Microsoft Bing and Xbox, they all run on Windows Server, okay? So we get to test our operating system and our internal cloud properties as well. So what is software-defined storage, okay? SDS for short. I mean, this is not something Microsoft invented. This has been around for a while. You could argue it's been there for 10 years or so. So it's basically, how do we put software intelligence delivering rich storage features on volume hardware? When I say volume hardware, it's not necessarily commodity hardware, but something that is available to a lot of customers and available in a way where we bring down a lot of innovations and touch that at breadth. And how can intelligent storage software light up those hardware innovations? What are the few inflection points driving the need for SDS? So let's talk about a few of those. One of the things is, as I alluded to before, cloud is hugely inspiring our design points, okay? Whether that be standard, server hardware. If Azure has deployed a lot of hardware, which is basically, Microsoft also contributes back into the Open Compute project in terms of the Open Compute server specifications. So we are also actively defining and designing our data centers. So Azure, in terms of as a customer, is buying a lot of hardware as well. And our goal is to kind of embrace, not just the Azure hardware, but other of our partner hardware design points kind of, and put our software on top of that. Evolving technologies, flash, okay? Today we have a mode where we have hybrid flash, but over time also we're going to see that, we will have all flash design points. Today all flash is targeted as primary storage. Hopefully the power and cost economics of flash comes down more, and I think it will get there. We will see other backup target applications as well. Networking. You'll see a great demo at the end. I don't want to steal Jose's thunder. Networking is going to go, I think 40 gig is starting to become mainstream. Then there's 100 gig. You can transport a lot of data pretty fast with 100 gig, okay? Maturity in software-based solutions. Okay, software SDS, as an industry, when we put this out there a few years ago, I think there's a collective learning we've all had, on how to better put guardrails around software-defined storage in terms of appliances. How do we deliver integrated solutions? Virtual machines and containers. We are at a very interesting inflection point in the industry today. When we made the move from physical to virtual, when I say virtual VMs, there's an interesting design point on how we designed for virtual machines, okay? And we are going to have the same inflection point and shift as we go from a world of VMs to VMs and containers, okay? Hopefully you heard us talk about Hyper-V containers and Windows Server containers, two technologies we are going to announce in future previews. And storage along those containers is going to radically shape and design how we see storage in terms of transient workloads, in terms of mobility, in terms of density and scale. Our data explosion, I don't need to tell you this, given the number of IoT endpoints and non-laptop endpoints, that's like exploding, okay? And they all need to connect to somewhere in the back end. And unstructured data analytics and structured data analytics is going to drive the need for storage. We see that inside Azure. We see that with our customers as well. And then lastly, scale out. Scale out has typically been an oxymoron where, we have tried to do a great job of scale out across the industry, but they're not typically easy to deploy. Scale out is going to be useful when you start deploying additional nodes in massive scale out. And those nodes are like very fluid, okay? They attach to the pool of scale out storage very seamlessly, with super ease, and you can manage them as one. And similarly, you can shrink and grow that scale out pool, if you will. So how we do it in a very simple manner around policies is going to be critical. So let me kind of spend a minute or so in terms of giving you the spectrum of storage. Storage can mean many different things. In the context of Microsoft, what it means is basically, let me first double-click on the customer. From a customer perspective, there are three clouds. The first cloud is Microsoft's public cloud. That's Azure, okay? Some folks are basically, who have certain types of workloads amenable to Azure. They will deploy that in Azure. Some customers are deploying their own private clouds. Big enterprises who say, hey, I need the cost economics of Azure. I'm going to deploy my own data center. I'm going to bring a lot of those design points in my own data center. And the third category is service provider or hosted clouds. So we have the goal is to have a consistent platform, not just how we see consistency in terms of APIs, but how do we see consistency in management, deployment, and things like that. Now, if you bring that down to storage, we offer a range of storage choices to our customers. So the first one is private cloud with traditional storage. Okay, we have our great SAN and NAS partner ecosystem, and we have a great story there. And that story continues. If you look at the install base today, that's all SAN and NAS storage. And in Windows Server 2016, we have, if you look at how we test, we have a variety of hardware we test with our partners, and that continues, okay? I just want to make sure I reassure customers, basically, that SAN and NAS, we have a great interop story, not just on functionality, but perf and scale and other end-to-end scenarios. The second category where we will spend a lot of time today is private cloud with Microsoft software-defined storage. Categorized as basically, we are calling it Microsoft Azure Stack as the overall entity. You'll see some storage investments, obviously, outside of Microsoft Azure Stack as well. But then there is the third category, where we call hybrid cloud. People who want the efficiencies of their on-prem, but want to extend the data center virtually into Azure, they could do so with hybrid cloud. We'll talk a little bit about Store Simple with Azure Storage in that category. And then the last category where you want pure public cloud storage with instant access to storage on demand, there you have Azure. So if you see the entire spectrum, this is something which makes us unique. I think we have our friends who offer one end of the spectrum or the other, but not the entire choice, okay? So I'd like to kind of, urge you to consider that and say that, hey, you're not locked into one or the other. You're not locked into private cloud. You're not locked into a public cloud. You have the best of both worlds. So with that, I'm going to hand off to Jose. Come on, Jose. And then he's going to take us through the SDS journey on what's shipping right now, what's available to you as customers today with 2012 R2.
Am I on? Cool. Good afternoon. So folks, the idea of this section is to give you a little bit of detail on where we are with our software-defined storage strategy in Windows Server 2012 R2, something you can deploy to production today. And the basics are in this diagram. You can see that we have in this stack, at the very bottom, you have a shared JBOD that is connected to a couple of file servers, and that constitutes your storage backend, right? And then through the SMB3 storage fabric, we connect that to a host of different consumers of that storage. It could be Hyper-V, it could be SQL. And we talk a lot about how this all comes together as a solution, and not forgetting the system center management that we have across the stack, right, end to end. If you look at where we are today with all these technologies, they work very well together. We have a great story there. Now, I want to highlight a few things. When we talk about having this file-based storage solution, there are concerns about performance and scalability. I hope by now, because we've been a few years into this, that you have heard about how this really has the scalability and the performance that you want. So at the very beginning of this, folks were saying, oh, can we achieve high IOPS? Can we achieve high throughput? Can we have low latency? I think we have proved over and over in the last 3 to 4 years that this is something that is available to you today through a variety of different hardware solutions, right? A key piece of this story is the scale-out file server, which is the notion that you have a set of machines that work together to create a cluster, and that you can access that storage through any of those nodes. That gives you that scale-out capability, meaning that if you have 4 servers, each with 10 gigabits of bandwidth, you can effectively achieve 40 gig of bandwidth if everything else can keep up, right? And if you lose one of those nodes, the other 3 nodes that were working there, they will keep everything running, and there will be absolutely no disruption in Hyper-V. So that's a key promise, right, that it's reliable, that it works well, that scales out, and will survive issues on the network, on the servers, and all that. That's a key piece. And more important, also the storage management that we're going to talk a bit later. In terms of storage spaces, that's a key component that lives on these file servers. Because, you see, before 2012, if you had a whole bunch of disks that you wanted to connect to a Windows Server machine, you had no way to transform, say, 100, 200 disks into resilient storage that you could rely upon even if some individual disk failed. So storage space has introduced that notion. So that's what gives you the ability to connect, say, 100, 200 disks to this Windows Server cluster, putting all those disks in a pool, and then carving out of that pool and giving you something like 2-way mirror, 3-way mirror, parity spaces. And this will give you the ability to have resiliency also to individual disk failures, to individual enclosure failures even. And you can actually use that with this high number of disks. You can actually go and have more performance because you actually combine the performance of the multiple disks together. And we're going to show some of this later. Important also is the ability that we have to do this in a way that not only performs well, but reduces cost, because you're basically connecting the bare components of the storage solution to your Windows Server. So those are the key pieces, right? You have the ability to use industry standard hardware, basic disks in a JBOD, and share those across multiple file servers. There is actually a session, the black box on the upper right is a link to another session. So there is a specific session that will dive deeper into design and configuration best practices for storage spaces. So if you're deploying this today and you have questions like, how many enclosures do I need? What's the minimum number of servers? How many disks? How many SSDs? How many HDDs? How many columns per virtual disk? If you have any of these questions, there's a deep dive that's going to cover all these things. So don't miss that one. The other thing is that we put a lot of effort into making this all very efficient. So we talk a little bit about the fact that we can combine hard disk drives and SSDs and give you a capability we like to call tiering, that will figure out which data is hot, which data is not, and move data to the right tier so you have the best performance. The same thing about finding data that is duplicated. So we have the capability to use deduplication combined with this solution. We also, on the Hyper-V side, we have things like, for instance, storage live migration that lets you move these files around with the workload running, or shared VHDX that lets you create a guest cluster using this file storage that is on your SMB3 solution. So we have all these things combined with management. And I have a slide just on management that talks about how we came from a situation where we had to manually deploy these solutions to something now where we can go to VMM and say, hey, I have these 3 machines. I want to create a file server cluster out of these machines. And VMM can fully automate the process of building these solutions. So you probably know that VMM can bare metal provision a Hyper-V host. But you might not be aware that VMM can also bare metal provision a file server and build a file server cluster out of that. It also can help with the notion of giving the right permissions to share. So if you're deploying all this with Virtual Machine Manager, which is part of System Center, you will have automatically grant the right permission to the right host, so you don't have to think about those as you create and deploy these virtual machines. They will automatically just work. Again, 2 sessions on virtual machine management, one specifically just on managing storage for Virtual Machine Manager as we have it today, and then roadmap for VMM. So this all comes together, right, as a solution. One of the things that we would like to talk about is the fact that we're not giving you individual components. When we were designing the scale-out file server and what we like to call the Hyper-V over SMB solution, we were always thinking about how do we manage this whole thing? How do we deploy it together? And nothing shows this better than CPS. CPS, our cloud platform system, has a lot of network compute and storage in a full rack that will give you essentially the ability to run a few thousand, 2,000 virtual machines, right? And what sits at the foundation, quite literally at the bottom of the rack, is 4 JBODs connected to 4 servers, right? Exactly implementing the solution that we've been talking about. So CPS has all this technology together in a single package. So it's a 4-node file server cluster connected to 4 JBODs, each with 60 disks, HDDs and SSDs there. You have the full resiliency piece. We have, for running VMs, we have triple mirrored virtual disks. For our backups, we use parity disks with deduplication. So the entire set of technologies is represented there, and is a solution that you can have from Microsoft today. If you're interested in details about this solution, again, look for the reference to the session on overview of Microsoft Cloud Platform System, where Vijay is going to give you all the details on how this is built. And you can actually have the details down to what kind of SAS connections are we using, what kind of disks, what kind of networking. So it's using all the technologies that we talked about here, but as a unit, also managed by System Center. All right. Another thing that's a great demo here on the expo area is the solutions that we're working with Dell, right? So you can have the entire CPS system, which is a partnership with Dell, but maybe you don't want the entire piece. You just want the storage piece of that. So we are working with Dell to provide with several different configurations that you can get directly from them. And we call them the predefined SKUs. So 2x2, 2x3, 2x4, 3x3, 4x4. What's that? That's the number of servers and the number of enclosures. So for instance, a 2x4 is 2 file servers connected to 4 enclosures. 3x3 is 3 file servers connected to 3 enclosures. And this will give you flexibility. There's different types of JBODs that will have more disks or fewer disks, so you can kind of have different sizes solutions, because really the CPS size may not be the right size for you. Maybe it's too big, and we can have different configurations there. So a great partnership with Dell, and they're showing this in the booth, both on the Dell side, where they have a system with shared JBODs showing there, so you can take a look at what it looks, and they have this solution there running behind glass. You can go take a look. And it's a full set of solutions using RDMA network interfaces and guidance and services along with that, and that's important. Again, there's a session where Klaus is going to actually talk together with the folks from Dell, describing this solution in much more detail. So I encourage you to attend that one. We also have other partners that are delivering JBOD solutions for storage spaces. You probably heard about DataOn, about RAID Inc., but maybe you haven't heard about HP. So HP is also now delivering JBOD solutions for storage spaces as well, right? And this is all about what we are ready to go to production today, right? We're talking about our 2012 R2 story, which we want to make sure that you understand is a solid story and has all the right components in place to be delivered. But and to reinforce that, we have a number of different customers that are telling us that this thing works, and this is very nice. 2 quotes there. One I like because it talks about performance, about having 450,000 IOPS, and the other one about cost, saying how they drop the cost per terabyte dramatically by going with that solution. And we also have a talk here by one of our partners that delivered this in a hosting environment. You might want to take a look at what they did to put all that to good use. But I know what you're thinking. How about this new Windows Server 2016 and the Microsoft Azure Stack? So back to Sid, and we'll have a couple of demos coming up on this as well.
Thanks, Jose. The mic back on. Great. Thank you, Jose. So again, just a quick plug. Go and check out the Dell shared storage, shared JBOD in the Dell booth. They have a great offering. They'll walk you through the different configurations and the types of workloads for each configuration. So let's fast forward to Technical Preview 2, which got announced yesterday. And for those of you who haven't downloaded the ISO or VHD, go and check it out. So that's kind of a bit zen, it feels like the Pacific Northwest. So as we continue the journey, I mean, when we started the SDS journey back in 2009, when we were planning for 2012 R2 and 2012, the fundamentals have not changed. Okay, internally we have a term called, SOAR, scalability, operability, availability, resiliency, reliability, and cost economics. So in the next version of Windows Server and Microsoft Azure Stack, we kind of focused on some of those key tenets around reliability, around scale, manageability, reduce cost. And as we go through the next few minutes, I'm going to kind of show you how we are kind of delivering innovations around each of these themes, if you will. In reliability, we did a lot of things around cross-site DR, and we also understand, the world is not reliable around us, especially sometimes with hardware, having transient failures. We should better adapt to those failures. So we did a couple of things there. Scale, as we scale, as we have more VMs, how do we manage and scale in a way where no one VM is hogging the IOPS, if you will, and it's kind of fairly distributed to everybody. Manageability, how do you adopt new OSs faster? Okay, it's great that we can give you all the innovation, but if you don't adopt it, it's very difficult for you. It's not going to make sense for you. And obviously, storage is a huge part of the overall data center cost. How can we bring down that cost for you so that you can unlock parts of your IT budget and devote it to something you need for your core business? Okay, that's what we are about. Okay, how do we kind of help you unlock out of your 100% data center, if it's 60% of your storage cost, how can we bring it down to a certain percentage, less than 60, and you kind of use that for the rest of your data center budget, or something up in the app tier. So let's kind of walk you through some of the scenarios. By the way, this is not the complete list. I mean, we had constraints of time. We're kind of selecting a few scenarios and kind of walking you through. So let's talk about storage quality of service. We started the journey on storage quality of service in 2012 R2, but it was very one-dimensional. It was, single node, only gave you the view from one side of the picture. When we looked at QoS all up, and we heard a lot of our customers, especially service providers, telling us that, hey, give me some way to control and monitor performance for VMs, okay? And especially kind of help me put some bounds on those VMs, some mins and maxes. So we kind of took that to heart and said, hey, how can we deliver something which gives you on a per VM basis, and it's very flexible. It can happen on a VHD. It can happen on a group of VHDs. It can happen on a VM, a group of VMs, or an entire service comprising of a bunch of VMs. Based in that hierarchy, you can define policies at very flexible ways with defined mins and maxes in terms of IOPS. So if you take a VM and you can take, hey, here's my SQL VM, okay? And within my SQL VM, my log VHD, okay, I need that log VHD to get, X number of max IOPS and Y number of min IOPS. You can designate that in the policy manager. And the policy manager and the rate schedulers that we have, the rate limiters that we have on the Hyper-V side and the policy manager that we have together, make sure that we are doing a fair distribution of IOPS across VMs, across the Hyper-V cluster, across the storage cluster. And we are doing that in a way where we are constantly adjusting and balancing that out. So this is a great, feature we feel for enterprise customers and service providers. It helps service providers to offer an up-level services like, bronze, gold, platinum SLAs, if you will, depending on, the amount of capability and there's opportunity to upsell. And for enterprise customers, depending on, your core CRP apps can get more IOPS, for example, okay? And your other departmental transient workloads can get low. So it gives you very good control. I urge you to check out, the session that we have, 3504. Jose Bejeto is going to be talking about this. This was Jose and Senthil's feature. And they're going to be going deep dive on this, showing you some great demos, so I urge you to check it out. Rolling upgrades. So another big feedback we heard was, hey, great, you're giving us all this, value in terms of Windows Server version shipping every n number of years, and that n is going to get smaller and smaller. But how do I upgrade to the latest version of Windows Server without having to do a very disruptive and a forklift upgrade? I mean, it's not easy today. So we kind of heard that feedback and went back and looked at, for your Hyper-V cluster, this is all this in the context of storage. It applies to Hyper-V and storage. How can we do rolling upgrades? So basically, think of it as if you have a 2012 R2 cluster, and you want to kind of go and take that cluster to Windows Server 2016, we will do that for you. We will do what we call, we walk through each node in the cluster. We drain those loads off. We upgrade that cluster. And then basically, we drain the loads back in. And we do that in a cyclical way where you kind of upgrade your entire cluster. And we can do that all without incurring any downtime. So you don't see any disruption in service. You could do this without needing to have a maintenance window, okay? So we operate in what we call mixed mode clusters. So you could have different variants of different OS versions. And once you decide that, hey, I'm running in mixed mode, all my patches are working fine, the HBA firmware all looks good, my BIOS update looks good, I'm in steady state, and my production workloads run fine, you throw the big red switch, you go to the new OS version, basically. And that's the point of no return. But it basically gives you a way to, really ease and enable easier migration and adoption of new OSs. So Rob Hinman and Ben Armstrong, Rob's in the cluster team, in our team, and Ben Armstrong in the Hyper-V team, they will show you a great demo and talk about this in their session. So go and check it out and learn more about this. Okay, so VM storage resiliency. So one of the things we heard is today in Hyper-V, when you have a VM and when there is no path to that VM, and that storage could be anything, it could be a SAN or a NAS volume or spaces or local, we are not very graceful about the loss of storage path to that VM. Okay, we sometimes behave in very unpredictable ways. And that's not good. So basically what we did is, as we are kind of scaling out and embracing more hardware, more volume hardware, we thought, we should be more transient to, storage path failures. Not just storage path, also compute as well. You will hear about compute in one of the Eldon session, he'll cover that. How can we be better and more tolerant to failures of the storage path? Every storage path has failed, the VM has no access to storage. So what we're doing in 2016, instead of thrashing that VM, we are going to be very intentional and put the VM in a pause-critical state where you gracefully shut it down, you checkpoint it. When the path to the storage comes back, we restart the VM, and it picks up from where it was frozen. So it's kind of cool. I mean, it doesn't have any interruption, any data loss, and it's basically a predictable behavior. And along the same line of dealing with transient failures, we are doing that also for switches. We are doing that also for the compute cluster. I urge you to check out Eldon's session tomorrow. He will talk a lot more about that, Eldon Christensen's session. Oops. That's not a good. Okay, so let's talk about it. Okay, we're back. So, and it happened just before Ned's scenario. So there you go, Ned. So storage replica. So let's talk about this scenario a bit. So when I go back to the cost conversation, a lot of CIOs and CTOs, when we had the conversation, we kind of say, hey, we need mission-critical DR today. If you see my workloads, around 20% of my workloads need mission-critical DR. That's across the river, basically synchronous replication, with zero data loss. But the solutions are pretty expensive today in terms of the hardware, software gear, the maintenance. I mean, it's pretty difficult to make. And it's a huge part of my IT budget. How can we please do something for us? And I need a single point of support, one neck to choke, if you will. So we kind of looked at that. We looked at storage replica, and we thought, okay, we have Hyper-V replica. Okay, that's at the VM level. Okay, do we need something at the volume level? And the answer was yes. So essentially, what is storage replica? It provides you synchronous replication. Okay, that means it's basically without any data loss. It works on any volume. It could be a SAN volume. It could be a NAS volume. It could be an existing storage spaces volume. Okay. Although the primary board is synchronous replication, it can also work in asynchronous mode. Okay. It needs, for the synchronous replication, it needs a 5 millisecond or less latency link. That could be your repurposed dark fiber, or it could be your remote RDMA. I mean, there's some cool gear we have with a bunch of our partners. So what this enables you to do is essentially in the synchronous replication mode, what we are essentially doing is when you're committing writing a byte on the local storage, you're also doing that on the remote side. And we are waiting for the ACK back before we commit to the app. Okay? So in essence, we are guaranteeing that the byte is written on the remote and the local copies at the same time. And there are two deployment modes for this scenario. One is what we call the stretch cluster mode. That's you have 7 nodes, 3 nodes in New York, and 4 nodes in New Jersey. Each of those 3 nodes and the 4 nodes have their local storage. Again, could be any storage, could be spaces or could be SAN, NAS. And then you have replication across the river with dark fiber, synchronous. If any of the nodes fail on any side or one side fails, the whole thing, the other 3 nodes or the 4 nodes takes over. Okay, that's what we call basically your stretch cluster mode. It gives you the current interface. Everything is settable through PowerShell. But for the stretch cluster mode, we have the deployment mode of the cluster admin console, which is your familiar admin console to set up clusters. You get that familiar admin console. The second mode that we have is cluster to cluster. That's 2 discrete clusters, each with their own storage, and you're replicating between the 2. Here, the experience is going to be Azure Site Recovery, ASR, and that's going to manage the orchestration of the workloads, just like we do with any other SAN partner today. ASR is going to be experience, and it also has the command line experience. So between the 2, it gives you, choices of deployment modes. It gives you ability to repurpose and use your existing volume. So we have a couple of great sessions tomorrow. One is going to talk about, the first session is how do you use failover clusters and storage replica together. Eldon Christensen and Ned are going to talk about that. And then the second session is Ned's session tomorrow about storage replica.
They're both Thursday.
Yeah, they're both on Thursday, sorry. So Thursday morning and Thursday afternoon. Sorry, it's not tomorrow, yeah. So with that, I'm going to hand off to Ned, and Ned will show us some cool demos. So go for it. Take it off.
Am I on here? You hear me? Oh, great. Good morning, everybody. Let me switch over here. Sorry? So I'm going to show you a quick demo today of a stretch cluster. So what I have, is the inability to Alt-Tab. Here we go. I already gave myself focus. So what I have here is a single VM running, just for the purposes of demonstration, on a 2-node stretch cluster. And one node is in Redmond, Washington, and one node is in Bellevue, Washington. They're actually not. They're both in the same rack. And we have these standards of business practices we have to do every year. I have ethics to disclose things. This simple VM right here is running, and it's itself is a single node scale-out file server. It's just a file server, and it's also running SQL. And what I want to do is demonstrate what happens if my stretch cluster loses the node where my VM workload is running. Now remember, these 2 nodes do not share any storage at all. They have only their own storage. They cannot directly access each other's storage. Only storage replica can keep that storage in sync synchronously the whole time. So keep that in mind. So over here, I have, if you want to come over to my little client machine. We have too many things running here. Whoops. Here. So this machine is just one in the middle. You can see, if you keep an eye on these little floaty guys I have down here, they'll tell you which machine I'm on. You can get lost real quick. So I made them all have different colors. And this machine right here is connected through SQL. Let me just start a SQL query. Whoops, invalid object name. That's nasty already. Let's not worry about that quite yet. Let's do this. I'm copying a bunch of files. These files are copying to that other VM right now, endlessly. And let me go on the O2 box, which is over here. And I'll run SQL over here so you can see that SQL is running. Yep. And here's my database. Here's my incredibly well-named tables. I've got the student stuff here. This is actually all working. You can tell this is a live SQL database running on this machine. SQL's happy, right? Get this little guy out of the way. And just to prove that I don't do any smoke and mirrors, let's just take this machine. And here's Bill Gates hanging out with the Secretary of State, John Kerry. And here's my share filling with files. Okay, this is still the same machine. And here's me. Or let's resize this a little bit. That's awfully big. I know I have a pretty huge head, but still. Okay. And just to prove there's nothing up my sleeve here. Oh, yeah. I'm hanging out with Bill Gates. Look how happy Bill is. Ned, you've done a terrific job. I don't really work here anymore, but you've really done a great job. I'm going to go and cure every disease ever. Yeah, but we are pals forever. Okay, so here's the proof. Now, this is my disaster. That's Jake. You'll see a lot of Jake on Thursday. If you stop by our booths, I'll give you some Jake stickers for your laptop if you want. What Jake represents is a giant explosion happening in Redmond. Hopefully I'm not there that day. I'm going to take my machine, that O2 machine, remember? The one that's running all my... Oh, you can't be serious. There. No, thank you. We're going to try this one more time. Don't you love KVMs? Establish a connection. You'll see this machine is running. We'll see that it's O2 that I'm on. Okay. Give it a sec. Okay, this is the machine. Here's the power button. Should I? I think so. Yeah. Uh-oh. Oh, wait. Oh, no. My VM! He's gone. So let's get rid of this guy. Yeah, I don't care about you anymore. And let's get rid of, let's see, where is O2's? Oh, is he gone? Yeah. Oh, he's gone. Okay, no more him. What's left? Here's my other node. Here's my VM. Interesting. Here's my storage. Notice how this time it's on Bellevue, not on Redmond. That all happened automatically. I didn't have to do anything except have a really bad disaster. Let's see if my VM's still alive. Obviously, it got rebooted. It was running on the machine. But let's see if I can get on it and do some stuff. Okay? So here's me. Oh. This is the problem with having a really secure password. Oh, yeah. Ah, yay, good eye, man. I heard somebody call it out. Test. That's why you're not supposed to use the administrator account. It's too hard to spell. Hey, look. I made it. Hey, look. My files. They all made it. They're all totally intact. They're all working fine. There's my house. Let's check out SQL. Database is still running. No damage, no problem. I wrote through every single I/O on both nodes. Every single one was synchronous. Every single solitary one completed on both servers. It is impossible for me to lose data. It's impossible for my cluster to die just because one site dies. If you come on Thursday, I have many more interesting things to show you, some of which no one has ever seen before. And I highly suggest you come to the Thursday 10:15 session on Stretch. and then really come to the 5 o'clock. I know the 5 o'clock one's kind of risky because you're all already starting to think about all the great bars on Rush Street. But trust me, you're going to get some really cool stuff out of that demo. Thanks, folks.
Thank you, Ned. Thank you.
There you go.
Thanks. All right. So let me move on to one more scenario, and this, I'd like to take some time to explain this a bit. And we feel super excited about this scenario. So when Jose talked about storage spaces, what's shipping today, that storage space has multiple scale-out file server nodes, and it has, what we call a shared JBOD. It's connected to the backend with the SAS fabric. We took that one step further. Basically, we have that great solution in market today that works, as you saw, it's designed and vetted in CPS. What we took is say that how can we enable storage spaces on a shared nothing architecture where you have a bunch of server nodes, in this case acting as storage nodes, and we just aggregate the storage across them. There is no backend SAS needed. There's no shared SAS fabric needed, okay? So this is what we are calling storage spaces direct, okay? So what it does, essentially what we are doing is this is how it works in Azure. We're kind of bringing that Azure design point and saying, how can you create your goodness of storage spaces with everything that you see today, with the storage pool, with tiering, with everything on a shared nothing architecture, okay? What it does is a few things. Let's just think about that for a minute. So you see the green light and the blue stripe in the middle? That's your high-speed SMB transport, okay? And using something what we call SMB direct that uses RDMA. So the nodes are communicating to each other using SMB direct, and that has all the fault tolerance and high IOPS, low latency attributes. We'll delve a little bit more on that later in the presentation. What it's doing is taking devices inside each of the server nodes. Think SATA, okay? Think NVMe. And it's making them shareable across the large pool of storage. That's what it's doing. So basically, it is unlocking your media and making that available to the entire pool so that your compute cluster can see every device in every node. And by the way, those devices could be SATA, SAS, HDDs and SSDs, and NVMe as well. One of the big things we are unlocking with Storage Spaces Direct is the ability to use SATA HDDs, basically, where we see the ability to use SATA SSDs. And we see a huge price point between SAS and SATA SSDs, okay? And we're going to embrace more media types as we go along. The other benefit of this is obviously you have finer-grained expansion on a per-node basis. When you need more capacity, you can add more capacity or more IOPS as you need by adding a node. And that addition of a node is pretty fluid, okay, as you will see. And when you add a node, the Storage Spaces Direct architecture goes out and rebalances the entire cluster in the background, okay, so that there is no hotspots on one particular node. So it takes care of all that for you, okay? The use cases here we see is Hyper-V as a backend to Hyper-V clusters, and also as a backup target, basically. Sometimes if you have a replication or a backup target, Ned talked about storage replica. I mean, all that data needs to be stored on the secondary site. You can use Spaces Direct on SATA, SSDs and HDDs, for example, okay? The other thing we have done is, the notion of what we call fault domains. We have the notion of, disk enclosure fault domains. What that means is when we are placing a certain storage space, basically, allocating a storage space, depending on the policy that you define, it knows how to place the data so that you're tolerant to a failure in the enclosure and also at a disk level and also at the node level. Think about it. When the entire node goes down, the data has to be rebuilt across all the other nodes, and it has to be kind of done in a very efficient way. That's where we kind of borrowed some of the parallel rebuild techniques, because doing that at scale is pretty complicated stuff, okay? Azure does this all the time. Azure has nodes failing all the time, and we're rebuilding all the time. A lot of the erasure coding techniques we took from Azure and put it down level here. So you see a lot of great innovation, a lot of Azure, a lot of goodness here where we are doing it at scale. And by the way, it can scale out architecturally. There's no limit. I mean, yes, there's kind of 64 nodes right now, but from a deployment and configuration, we are going to be taking a smaller nodes based on customer feedback. So let me kind of flip to one more key thing. Before I go there, I just want to point out Klaus Jorgensen. He's the PM for this, along with other team members. Klaus, come on up. He has a session on this, which he'll delve into on Storage Spaces Direct. Come by our booth. You will see a lot of demonstrations there. I want to basically talk about one more thing here, which is critical to Storage Spaces Direct. I talked about Storage Spaces Direct being shared nothing storage across a bunch of server nodes. So you can deploy this in two modes, what we call on your right-hand side. We are showing what we traditionally call converged or disaggregated, where we have storage and compute in two separate tiers. Okay? You have basically your Hyper-V cluster that goes over a high-speed SMB3 storage network fabric and talks to your storage cluster. Okay? You have that today with the solution that we showed in CPS. You can do the same thing with Spaces Direct. It gives you the independence of scaling each tier independently. So depending on your workload, you could scale compute or scale storage, but not having to scale both. There are certain design points where we feel where collapsing these two tiers into one, where you have the compute, network, and storage running on discrete nodes, on the same nodes, and you're going to, if you need more compute and storage, you kind of add one more. Okay? This is also, in the industry, sometimes it's called hyperconverged. We're also going to be supporting that as well. So we don't want to lock you into one or the other. We feel you as customers will make that choice. And the choice is going to be made on certain types of applications, how your admin structure is designed in terms of your Vert, storage, and Fabric admin, which segment of the market you're in. Are you in a small branch office, or you're a mid-tier data center, or a large-scale data center? So we are giving you the choice, and right now in Technical Preview 2, we are supporting the disaggregated or converged mode, and also you are welcome to play around with the hyperconverged mode as well. So all this is great, but it's, again, I go back to the philosophy, it's a bunch of bits, right? So this would be meaningless if we didn't have a bunch of key partners around this, okay? So we are working very diligently with our 7 partners at the moment. We are calling them development partners. This is not any specific hardware. We have a very prescriptive Spaces Direct reference profile, if you will. We need to make sure that a lot of things across the internode communication has to have the right latency. We have our certified HBAs, your RDMA adapters, hard drives, NVMe devices, you could name it. So we kind of work with each of our partners, and these model numbers you see are very specific systems where this has been validated, tested, and gone through some comprehensive testing, okay? And we're going to basically continue the same partnership, and our partners are going to offer this in terms of their solutions. I welcome you to check out 2 configurations that we have in the Cloud Platform booths. We have the Dell Storage Spaces Direct on the 730XD configuration. That's the one in the middle. And we also have the HP design as well in our booths. So you're welcome to check that out, ask more questions, and visit Klaus's talk on Thursday.
Yep.
So with that, I'm going to basically give the floor to Klaus. Klaus is going to give a demo on Storage Spaces Direct.
Thank you, Sid. My name is Klaus Jorgensen. I've spent the last couple of years or 3 working on Storage Spaces Direct. So it's my pleasure to speak to you today about it, or actually do the demo since you already heard Sid speak about it. And I will be showing my head from time to time in our booth down in the expo floor, so you can come visit me, ask more detailed questions, and also tomorrow in my session tomorrow afternoon at 3:15. But enough of talking. Let's actually see some action. What you're looking at here is a glimpse into a clustered system that runs Stored Spaces Direct. And I specifically looked up the device manager on one of the nodes so you can see what a node looks like. So try to highlight that this list of disks that are all the same is all SATA disk devices that are sitting in some enclosures. But the key point I want to point out for you is the 4 devices at the bottom you can see are NVMe devices. And I'm not sure if you're familiar with NVMe devices, but NVMe devices essentially flash data, flash SSDs that are sitting in the PCI bus internal to the computer. So by definition, that device, this device cannot be shared with other computers without software. So to highlight that, I'm going to bring up the failover cluster manager. So what you're looking at here is, I'm just going to switch to the nodes. So you can see that I have a cluster that consists of 5 nodes. And looking at the pool, I created a pool that effectively spans across all 5 nodes and brings together these 4 NVMe devices from each node, plus all the SATA HDDs that you saw. And so that's why you can see exactly 20 NVMe devices in this list. 4 devices each, 5 nodes gives 20. You're more than welcome to count if you don't believe me, but there is 20. So that is how we use the power of software to bring together all these hardware nodes and bring a single pool across the entire system. Now, once we're done with that, we then, on top of the pool itself, we define what we call virtual disks. A virtual disk defines the resiliency properties, etc. And if you're familiar with storage area networks, that's what you would know in a storage area network as a LUN. And then on that LUN, we have some shares, and on those shares, we run Hyper-V. Right? So let me switch to another machine. So this machine, I actually have the top bucket of computers. I got like 8 Hyper-V machines that is already running some VMs that are consuming this storage system. I actually configured all the VMs with storage cost that was mentioned earlier to push the I/O down so you can see the difference. So that the bars you see at the top here represents the throughput in the disk storage system on each of the 5 nodes. And you can see 4 of them are really active. That's because this was originally a 4-node cluster, and I expanded it with a 5th node. And now I'm going to show you how we do rebalancing, because I'm effectively expanding my cluster from 4 to 5, and then I'm going to kick off the rebalancing process. And you can, if you notice, you will see that there's going to be some additional activity shown on the disk system that shows that we are actually moving data from the existing nodes over on the new node. So let me kick that off. This is a single command. I'm going to start to rebalance the pool. First, we go out and look at the data layout. We analyze the servers and see where all the data pieces are. So look at, I have not created any new virtual disk to consume that space. What the system is doing right here is it's reading data from the other nodes and moving it into the 5th node so that we consume an equal amount of storage on every single node, so that I can use that 5th node for additional performance and capacity in the system. So what you saw was first Storage Spaces Direct, how we can bring disk devices together that are not physically shareable in a single pool and expose that effectively up through the layers to hypervisors. And then while the system is running with VMs active doing all sorts of work, we can rebalance, we can expand the system, we can rebalance the data onto the system. And this, since this is a fairly large system, we have about 120 disks here, the rebalancing process is going to take a few minutes, or maybe a little longer, depending on how much data is there. So I'll cut the demo short here, but come tomorrow, we got 4 more demos than these 2 to show around Storage Spaces Direct, and also the cool innovation we're doing because we're starting to utilize REFS as the primary file system with Storage Spaces Direct, which will unlock a few scenarios that I think you'll be very interested in hearing about. So thank you.
Thank you, Klaus.
Can you switch back? Yeah. And by the way, your session is on Thursday, not tomorrow.
Sorry.
Yeah.
I'm ahead of myself.
Yeah. You're going to have a...
I'm so excited to do it.
Yeah.
Can't wait.
So Thursday. Go check it out. Thank you, Klaus. So let me just fast forward and move on a bit quickly. Pick up the pace. So storage health monitoring. One of the learnings from our customers is when you start putting together systems at scale, root causing and diagnosing at scale is a completely different ballgame. I think when we started diagnosing the CPS, the cloud platform system, the storage problems, there's a lot of learnings we gleaned from that and kind of put that back into the product. So this is one great example where if you see the storage stack, all the way from the file share to the volume, all the way to the physical disks and layers, the physical enclosures and the pools below in the middle. Earlier we have discrete logs and views at each of these layers. We never had a holistic view of what's happening in the stack. So we kind of did some innovations around consolidating all this logs so that you have one place to go and look to diagnose your problem. If something happens on a spindle, how does it manifest itself way back up in the share? We're kind of doing the correlation for you and putting it in one. It's a great thing, very easy to diagnose, command line. If you love command line, you're very easy to diagnose, and go and check it out. Let me kind of switch gears and talk about this new scenario. I should just first call out, this is not available in technical preview 2. This is going to be announced. This is going to be delivered in a future preview. Azure Consistent Storage. So before I kind of talk a little bit about this, I mean, if you have used Azure, Azure has the notion of Azure blobs, Azure tables, Azure queues, and also Azure files. There are different types of objects and paradigms you get in Azure. So we're kind of taking that and making that available on-prem. Okay, we're going to start with blobs and tables. Okay, why are we doing this? Okay, so what this means is basically if you are a developer codifying to a set of Azure storage APIs today in your public cloud with your favorite cloud-born app, and you want to run the same app on-prem, okay, whatever the reason, it may be control, compliance issues, or whatever, you could do that. You could run the same app on-prem. So it gives you the API surface area and consistency between Azure and on-prem. Okay, a lot of customers have asked for that. Basically, where some of our customers, they start in the cloud, in the public cloud, and say, hey, give me the same functionality on-prem. So we're kind of delivering on that journey. And from a Fabric admin perspective, the blobs and tables layer sits atop the traditional storage stack that we have, okay, with our scale-out file server or with Spaces, or it could be hyper-converged. So it has all the goodness of all the value you just saw before this, okay, and it kind of adds up. It gives you, so in a nutshell, it gives you, with our stack, you get blobs, tables, file, and of course, you obviously get, we have iSCSI and NFS support. I'm not talking about that. You get that as well. So you have multi-protocol access, okay? I encourage you to check out Mallikarjun's presentation tomorrow. Sorry, I'm not sure. I think it's tomorrow. And check it out in terms of blobs and tables. He's going to talk about this, do a few cool demos, and go and check it out and have fun. So let me do an infomercial. Wait, there's more, basically. Yeah. Jose is giving me that I'm running kind of low on time there. So I'm going to speed up things. We did a bunch of things around SMB security, around dedupe scaling. We optimized dedupe to enable parallel optimizations, supporting large data sets. We improved ReFS. ReFS has a better together story with Spaces in terms of, creating and merging of files. And we have done a bunch of things around storage spaces manageability, which you saw. A lot of that is showing up in Spaces Direct. Let me kind of leave you before I hand off to Jose back again. From a Microsoft perspective, we give you choice. I mean, you have a great story today with your SAN and NAS partner, and we support that story. We're going to do that. We're also offering an alternative. And from a value prop perspective, you have a SAN NAS story. You also have a Microsoft SDS story in the 2 deployment modes we talked about, converged or hyper-converged, with all the value props you see. So with that, I'm going to maybe do just a couple of things on, talk a little bit about Store Simple. How much time do we have? 10 minutes? Yeah. Just do a quick minute shout out to StoreSimple. So far we have talked about private clouds. StoreSimple is a hybrid cloud story, basically where it works with any server, file server or Linux file server or VMware. It attaches behind that. It's an appliance. It sits between the servers and between Azure. It looks at the cold data and the warm data and kind of pumps it back into Azure. Okay, so a lot of goodness here in terms of unlocking capacity, causing you not to kind of fret and think about the next hardware purchase. You can put that data into Azure. Go and check out the StoreSimple talk tomorrow, the talk track that we have around StoreSimple. And we also have the device and the booth back in the private cloud platform area. And last but not the least, for folks who want public cloud, we have Azure Storage, hyperscale, huge scale. Mark Russinovich talked about 50 trillion objects, blobs, tables, queues. You have all that goodness in Azure, basically, and if you're using Azure, great. If you're not, kind of go and check it out. A couple of great sessions in Azure as well. This is the part Jose has been waiting for. So while Jose is setting that up, let me kind of talk a little bit about kind of the future after the future. So as we look at the world going largely scale out, there's going to be a lot of nodes. These nodes are going to have different media types, okay, which are evolving. And they need to be connected by a high-speed fabric, okay? That high-speed fabric today is sometimes 10 gig or 40 gig. And that fabric has to be low latency because you need to ship data closest to your app, okay? You need to do it in a way where it is faster than local access. I'm going to leave it at that and ask Jose to give a quick demo and have some fun.
All right. So I always like to do a little bit of perf demos. And we have something interesting new in the industry happening, both in the area of storage technologies and also in terms of networking technologies. So we are making a lot of these software-defined investments, and they rely on the fact that we can actually get great storage performance and very, very low latency, high throughput from these systems. So I'm going to run a little demo here, and I want you to follow me through this. So we have two machines. One machine is going to be my client machine, and it's called Iggy1. And the other machine that I have here is my server machine. That one is Iggy2. So it's a simple client and server scenario. We have an SMB server and an SMB client. Now let's look at the configuration of that SMB server. So if you look at what we have in terms of storage here, I hope you can all see, we have 16 SATA SSDs. So we work together with Micron. They have us running a few of their SSDs here. And we created a pool out of this, as Klaus was saying. And out of that pool, we created a virtual disk, right? And the notion is, with that volume that I created on top of the virtual disk, I'm going to see what the performance looks like. So 16 SSDs, what do you think we can get in terms of throughput? Not bad. So if you look here, the big number there, we have 8.3 gigabytes a second. That's great performance. And I also want to call your attention to the average disk seconds per transfer, which is 3. That's 3 millisecond latency. So we are drawing from the system, 16 SSDs, a whole lot of throughput, okay? So that's so highlighting the number there, 8.3, and that's all great. But this is only local. So this is my machine talking to the SSDs directly connected to my server, okay? Now, in order to demonstrate what I want to demonstrate, I want to actually go and do this remotely, okay? What do you think you're going to do? So if you look at the number, 8-point-something gigabytes per second, it's kind of a hard thing to deliver over the network because there's a lot of bandwidth. But we have here a card from Mellanox that's a Connect X4, which you probably haven't seen before. That's a 100 gigabit networking card. So out of a single port of that NIC, so that's one cable between two machines, look at what I'm getting there. So remotely accessing that storage, we have 8.3 gigabytes a second. And look at the latency number, the average seconds per data request. It's absolutely the same number. Actually, it's not the same. It's a few hundred microsecond difference. But you can even tell because Perfmon operates at a millisecond range. So we were like 1 digit off that measurement, okay? So this is excellent performance. And you cannot deliver that with a single 10 gig or even 240 gigs. It's almost scratching that performance. And we are delivering all this out of one port of one NIC. That would have been great, okay? But maybe we could do a little better than that, right? But the problem is with the 16 SSDs, right, we have about 400, 500 megabytes a second, so times 16, that's all you could get. But our friends from Micron gave us a few other devices to play with, and we have there 3 NVMe devices. And guess what? We can create a pool out of that, and then we can create a volume on top of that. Any guesses? Because this is connected directly to the PCIe bus, right? So it eliminates a lot of the work that we had before. Let's run the same workload. So we're doing a whole lot of 64K IOs. So locally, on that system, we have 11.2 gigabytes a second out of 3 SSD devices. Okay? We had 16 before, now we have only 3. Now look at that latency. What does it say? 1 millisecond. So that's the beauty of what's happening in terms of hardware, right? We get better hardware, lower latency, fewer devices, and we get much better throughput, and everything is functioning perfectly locally. But now, I know what you're thinking. Can we do that remotely, right? Well, if you do the math of what 10 gig means, how much data can we do over 10 gig? 1 gigabyte per second, give it or take. How about 100? Well, let's run it. So we're doing remotely over a single port of 1 gigabit Ethernet, 11.1 gigabytes a second. That's the highest number I've ever seen out of a single port anywhere. Now, more important than that, look at that latency. 1 millisecond. We didn't even touch 2 milliseconds yet. So this is SMB 3 talking over 100 gigabit networking to a set of NVMe devices in a store spaces configuration. Okay? Now let me show back here in the slides what you just saw, right? So what you saw, just to be clear, is 2 machines directly connected through one port talking to a storage server that has 3 NVMe devices, okay? So now, if you think about it, this is 2 machines, right? But these are the building blocks that we are using. I know this is a technology demo, right? This is a new NIC that just came out. We got it hot off the press. The devices from Micron are also prototype devices. And this is the pre-release operating system. But imagine what we could do if we combine what Klaus just showed with these new technologies, right? Maybe even in a hyperconverged form. So that's the idea that we had here, to show you a little bit how our platform will keep up with these things. And I'm dying to actually get my hands in more of these cards and maybe have like a multi-channel 2 times 100 or something. But we'll save that for another day. Okay?
Thank you, Jose. Thank you, Jose. Thank you, Micron, Mellanox, for the samples there. We'd love to hear from you. I think we'll take a lot of questions offline. We don't have time for questions here. A couple of things. We have the Windows Server user voice. We have the link there. You can go in and click on storage, give us feedback, and we have a link to the experience guides where you can go in and try the scenarios with TP2. Have a great show. Thank you very much.